So we know how to find our mean, median, and mode, and we know how to find our standard deviation now. But the reality is we need to know what it is used for. Anand is very excited about finding how to use his standard deviation today. So we are going to look first of all in terms of what a normal distribution is. So if we have these three examples, something that can be described as a normal distribution is actually symmetric about the mean. You've got a set of data that has a maximum in the middle of everything, where about 50% of the data is going to be to the left and about 50% of the data is going to be to the right. We really like information that or sets of data that are normally distributed, because we can try to make some sort of inference of what's going to happen next. We can use it in order to look at all of the data, but before we can get to that point, we have to be able to tell whether we have a normal distribution or not. We are still working with univariate data, but within that, we can actually make a histogram to tell whether our data is a normal distribution. The first problem that you all have on that page actually has already done the histogram for you. We have a set of data, and so if you take that like 100, here we've got 100, we've got 1, 2, 3, 4, 5, 6, 7 100, so that's why the frequency is 7. So we've created this histogram, and if you notice, 100 is the middle of the set of data, and it is also the highest frequency. And then to the left and the right, they are somewhat symmetrical. It's not perfect. And then one step down more, we actually have symmetry at 2 for 80 and 120. So this actually is going to be considered a normal distribution. I need all of you to pick up a writing utensil so that you can make a histogram for the next two sets of data to decide whether they are a normal distribution or not. If we look at 22, we have to count the frequency of 22 in our set of data. So that's actually 1, 2, 3, 4. And so we are going to go up to 4 in our histogram for 22. If we then go to 24, 1, 2, 3, 4, 5, we have a frequency of 25.
You keep missing the kid. You can come in.
So if we have 25, we have 1, 2, 3, 4. $27 is going to be 1, 2, 3. Please go in Miss Little's room, Bryce.
Bye, Bryce.
And then for 29, we are going to have 2. So if we're looking at this set of data, it is obvious that the highest is not right in the middle. It is skewed. This is not going to be considered a normal distribution. If we go back to our original, anything that is positively skewed is going to have that symmetry closer. It's not really symmetrical. It's actually closer to the y-axis, where negatively skewed, you're going to have that spike further out. So if we had to describe this set of data, it would actually be positively skewed. The first set of data actually gave us the univariate. It gave us all of the data, and we had to figure out the frequency ourselves. Our second set of data, they've already done that for us. It kind of confused some of my students in the last class because they wanted to count up the number of ones. But what this is actually telling us is our shoe size and the number of students that have that shoe size. So our frequency is already coming here. This is our frequency. So if our shoe size is 4, how many students have a shoe size of 4? 1. For a shoe size of 5, we have a frequency of 2. And I'm just going to continue to complete my histogram. Eight is going to go to 5. 9 is at 1, and 10 is at 2. And so because it has that nice spike in the middle and everything, it's not perfectly distributed, but it's pretty good. This is going to be a normal distribution. Now, why we even want to know about a normal distribution comes from looking at what is on the next side. Our next side has, our next side actually has some information about a normal distribution, and it's called the empirical rule. It tells us that if we have a normal distribution, the graph is maximized at the mean. It's going to be right in the middle. And if we go 1 standard deviation to the right and 1 standard deviation to the left, 68% of our values are within 1 standard deviation. This is 68% of our data. Even more importantly, what I think is even more interesting is that if you go 2 standard deviations to the right and the left of the mean, that is about 95% of your data. And if you go 3 standard deviations to the right and the left, that should be 99% of your data. In terms of anticipating, trying to figure out what to prepare for or what you can plan on, this is actually pretty interesting. At least I think it is. So, you all have a really nice graph there on your sheet of paper. I actually don't have it. I didn't cut it in to my notes. But it tells us that the heights of players in a basketball league are normally distributed with a mean of 6'1". So that tells us our height is going to be 6 feet and 1 inch. And then a standard deviation of 2 inches. That means we are going to add 2 inches in order to find our next height. If we are at 6'1" and we add 2 inches, we're going to go to 6'3". We're going to go to 6'5". for our second standard deviation, and we're going to go to 6 foot 7 inches for our third standard deviation. In the opposite direction, we are going to subtract 2 inches, so this is going to be 5 foot 11 inches. This is going to be 5 foot 9 inches, and this is going to be 5 foot 7 inches. Our first problem tells us to find the probability that a player will be selected at random that will be shorter than 5 feet 9 inches. Well, we can see that this is going to be all of this, right? It's going to take us to 5'9". And the area between these two is what percentage? If I go from 2 standard deviations, right? 2 standard deviations is going to be 95%. But I only want from 5'9" or below. So if all of this is 90%, what do I have left? Well, a total of 5%. And then in order to, I've got to divide it by 2 because I only want lower. I don't want all of the people who are taller than 6'5". I want just the people who are shorter than 5'9". So if that's only 5%, then your probability of being shorter than 5'9" is 2.5%. Let's look at the next question. If there are 240 players in the league, about how many players are taller than 6'3"? Well, we started at 6'1", and then we went 1 standard deviation to find 6'3". Now, if you think about your standard or your normal distribution, this is 68% right here, but half and half is going to be 34 and 34. This is 95%, right? Well, you can look at it this way. This has got to be 50, right? So if this is 50%, and from here to here is 34, then this is going to be 50 minus 34, which is 16%. Now, is that my answer to the question?
No.
No. I want 16% of 240. So it's up to you how you figure this out. A lot of my students today have done 0.16 times 240. And then they've gotten 34 or 38.4, right?
Yeah.
Can you have a 0.4 of a person?
No, you won't.
No, so it's going to be 38.
You don't find out.
Not necessarily. You don't always round up. You can also do, how many of you remember percent over 100 equals is over of? If I want 16% of 240, we can then cross multiply and do 16 times 240 and divide by 100. That will give you the same answer as 38.
Oh, man.
We can use this in order to figure out how to anticipate what's going to happen next. And like I said to you all, I've said several times this year, mathematics, if we're talking about why it's useful, if you're working for a large company, huge companies have actuaries who their whole job is to anticipate what's going to happen next. This is just another way that we can anticipate with a set of data where our values are going to lie or what's going to happen.